Alright, this is integrals, day number 3. A little bit more on Archimedes plus some integration review. Alright, I'm going to go ahead, I think this is x cubed. I'm going to go ahead and lay this out, and I'm going to save myself a little bit of time here, and you as well. And I'm going to go from 0 to 2. Okay, here are my number of triangles. N number of triangles, width 2 over n. The interval is a length 2, and the height would be f of 2k over n. So let's go ahead and set up the area function here. So the area would equal the limit as n goes to infinity of the sum from k equals 1 to n of what we have here. So here is our height function, 2k over n cubed, plus, I'm just going to call that for now 12k over n plus 2 times our height, times our width of 2 over n. Alright, so as we go ahead and we split this thing up, I'm going to just kind of regroup some stuff here. K equals 1 to n. I'm going to turn this first term into, it looks like 64, right? 2 cubed would be 8 times 8, so 64k cubed over n cubed. Alright, then I have plus 12k over n plus 2 times our width 2 over n. Okay, let's keep doing some work here. That would be the area, which would be the limit as n goes to infinity of, let's bring that width in now, k equals 1 to n. So I'm going to distribute this term to each of those three. So that would be 128k cubed over n to the 4th. Okay. Plus 24k over n squared plus 4 over n. Okay, now I'm going to split that up into 3 separate summations. So that would be the area is the limit as n goes to infinity of the following. It would be 128 over n to the 4th times the sum from k equals 1 to n of k cubed plus, let's split this second term out, 24 over n squared times the sum from k equals 1 to n of k plus, split this out, 4 over n times the sum from k equals 1 to n of 1. Alright, so here we have a new limit. Now we can take the limit as n goes to infinity of all of these items, but first I have to do a quick substitution. So we can see that k cubed would equal this. The limit as n goes from 1 to, or from k equals 1 to n would leave us with 128 over n to the 4th times, and this thing I'm just going to write as n to the 4th plus a bunch of other terms because it won't matter, over 4. Alright, in the second term I'll have 24 over n squared times the quantity, of course this is k, so that would be n squared plus some other stuff, which in that case would actually be pretty simple, but I'm not going to go ahead and work that out. just for the fact to keep it simple. And then it looks like if I have a constant, I just get n. So this would be 4 over n times n. Alright, so I'm going to take the limit of that thing as n goes to infinity, and that should give me my area. What does that mean? What does n going to infinity mean? That just means that we're going to take and we're going to make an infinite number of intervals along this one interval. So we're going to make those rectangles infinitely small. So you'll see you get your ends to the end of the fourths cancel, your end of the seconds cancel, your ends cancel, and in turn you get this 128 over 4, which is 32, plus 24 over 2, which is 12, plus 4, which I believe gives us an area of 48. You can always check to see if that's true. Take your interval 0 to 2 of your function. 8x cubed plus, what is it, 6x? Yeah, 6x plus 2. Integrate it. Use the fundamental theorem of calculus. And you'll go ahead and you'll most likely, hopefully, get that area of 48 units cubed. All right, little review there of Archimedes. Okay, so integration. Earlier we showed that the antiderivative of x squared is 1/3 x cubed. We showed that any function of that form where c is a constant has a derivative of x squared. We say that the indefinite integral or integral of that x squared is 1/3 x cubed plus c. And write that the integral of x squared equals 1/3 x cubed plus c. We read this as the integral of x squared with respect to x is 1/3 x cubed plus c. So basically just our normal integral notation. Just don't forget about c on the end. Okay, so here are a couple of examples. Right? Some basic ones with the square root of x and x to the fourth. So let's discover some integrals in a different way on the next page. Alright, so let's find the derivative of this function here. Okay, so the derivative of that, right, if we put this in power rule form, derivative would be bring down the 1/2, take away 1, which makes that a negative 1/2, and then multiply by 5 by the chain rule. So 5x minus 1 to the negative 1/2 is really the square root of 5x minus 1 in the denominator. So that's our derivative. So using that idea, we know the integral of that equals this. So therefore, then we know that the integral of 5 over 2 times the square root of 5x minus 1 dx equals this plus c. So if I pull the 5/2 out, I'm given that the integral of 1 over square root of 5x minus 1 equals this. So in order to turn this into what I want to solve for, I multiply both sides by 2/5, and I got it. Now I didn't distribute 2/5 to the c, because that would just become some other constant which we don't know the value of. So that would be discovering an integral using the derivative. Alright, so here are just a few rules that we need to be aware of. Right, be aware of these derivatives and integrals. Derivatives one way, integrals the other. And be prepared to use them. Alright, so we got an assignment here. Let's maybe do a couple of these. Let's start with number 1. So if y equals x squared, find dy dx. Well, so basically I know that 7x to the 6th is the derivative of x to the 7th. Therefore, the integral of 7x to the 6th dx is equal to x to the 7th plus c. Hence find the integral of x to the sixth. Well, if I want x to the sixth, I would bring the 7 out in front. And therefore, then, to get that all alone and find the integral of x to the sixth dx, I would multiply by 1/7. And there you have it. Discovering integrals. Let's try one more. How about number 3? Okay, the derivative of e to the 2x plus 1 would be itself times the derivative of that exponent. Therefore, the integral of that dx is equal to e to the 2x plus 1 plus c. Okay, so if I want the integral of e to the 2x plus 1 dx, I pull out the 2. And so the integral of e to the 2x plus 1 dx would equal, multiply both sides by 1/2, 1/2 e to the 2x plus 1 plus c. Alright, if y equals 1 over the square root of x, let's write that in a different form. How about x to the negative 1/2? Find dy dx. Well, dy dx would equal, that would be negative 1 over 2 times this, x to the 3/2 power. Okay. So let's find the derivative, or the integral, of 1 over x times the square root of x. Before we do that, let's rewrite this in a way that may make a little bit more sense. Okay, so I'm going to write x to the 3/2 as x to the 2/2 times x to the 1/2. And x to the 2/2 is just x. X to the 1/2 is square root of x. So you might, it's just a foreign way, right? X to the 3/2 is another way to write x times square root of x. So this would be negative 1 over 2x square root x. So let's find the integral of 1 over x square root x. So I know that the integral of this, right, the integral of negative 1 over 2x square root x dx is equal to what I started with, which is square root of x. So if I want the integral of just 1 over x square root x, I pull out that negative 1/2. I forgot the c, but I remembered it before I was finished, so that's good. So the integral of 1 over x root x dx would equal negative 2 root x plus c. Alright, let's see here. Yeah, let's do this one. Alright, so what would dy dx be here? Well, that would be dy dx would equal derivative of the outside, which would be cosine of 1 minus 5x, times the derivative of the inside, which would be negative 5. So dy dx in simplest form would be negative 5 cosine of 1 minus 5x. Okay, so that tells me the integral of negative 5 cosine of 1 minus 5x dx is equal to sine of 1 minus 5x plus c. Alright, factor out that negative 5, and that gives me the integral of 1 minus cosine of 1 minus 5x dx. That's equal to sine of 1 minus 5x plus c. And therefore, the integral of cosine of 1 minus 5x dx is equal to negative 1/5. That's a 5. Sine of 1 minus 5x plus c. Alright, one more. Let's consider this. What is the derivative of that? Well, the derivative of natural log is 1 over its inside times its derivative. So that would be 1 over 5 minus 3x plus x squared times the derivative of the inside, which would be 2x minus 3. Okay, so dy dx is equal to 2x minus 3 over 5 minus 3x plus x squared. Okay, so that tells me that the integral of 2x minus 3 over 5 minus 3x plus x squared dx is equal to the natural log of 5 minus 3x plus x squared plus c. Okay, how is this related to that? Well, that would have to be two of these, right? Because I see a 4x minus a 6. So if that's true, then the integral of 4x minus 6, of course I can't multiply on one side and not the other, minus over 5 minus 3x plus x squared dx will equal 2 times the natural log of 5 minus 3x plus x squared plus c. Another form you might see this in might be the natural log of 5 minus 3x plus x squared quantity squared plus c. Right, because this can be brought up as an exponent for this trinomial in here. Alright, either of these two would work just fine. Alright, let's do number 14 here. So the derivative of arctangent of x, dy dx, is equal to 1 over x squared plus 1. Alright, so that tells me that the integral of 1 over x squared plus 1 dx is equal to arctangent of x plus c. Now if I want negative 3 times that, I got to do negative 3 times that, and that's our integral. Alright, we are done with day number 3 on discovering integrals. This backwards method of thinking is honestly going to help tomorrow and the day after when we start talking about use substitution, integration by parts, and change the variable integration. So that's it. Peace out. See you next time.